Good morning, everyone. Let's get started. My name is Joost van Dijk. I work for Yubico as a developer advocate, and I'm working on a project together with two other organizations on digital identity wallets. And as you may know, Yubico is also involved in FIDO with security keys. So I'd like to talk about this project where we try to secure a digital identity wallet with FIDO security keys. So let me first give some context. In Europe, as you may know, there is this amendment to the eIDAS regulation, which mandates that every member state in the EU will need to build a digital identity wallet for its citizens. So I think there's now 27, so I keep forgetting after Brexit how many states, but like 27 states, they will all need to deploy at least one wallet. And that means that there will be over 400 million people in the EU using wallets in the near future. So right now there's several pilots going on to test out the technology, and lots of people are building wallets. Now most of these wallets, they are native apps on Android or iOS, but we like to do things a little differently. We're trying to do the same using pure web technology, which means that this wallet, which we call a web wallet, can run in your browser, which means that you don't actually need a mobile device to use your wallet, which is beneficial for some use cases. You can just run a web browser. It doesn't mean that you have to have a desktop browser to use it. You can, of course, also use it on your mobile phone, but you're more flexible in using it. So we call it, so this was a temporary name, WW Wallet, but actually it kind of sticks, so we're still using it to stress the fact that it's a web wallet. So this is a collaboration between GUNet, SUNet, and Yubico. So GUNet and SUNet, they are in the NREN space, so the higher ed space in Europe. So SUNet is the Swedish National Research Network. GUNet is the Greek University Network, and Yubico is that's us. So we're building this wallet, and we try to protect it using FIDO security keys instead of the secure elements that are available on mobile platforms. So this wallet has to do, needs to do two things. It has to, of course, act as a wallet in the sense that you can store your personal information on it, but it also needs to provide digital signatures. So those are two requirements in this eIDAS regulation. So just to give some context, it doesn't mean that this is restricted to the EU use case. Any wallet can actually do this. Also doesn't mean that you have to use a web wallet. You can still build a native app and do the same thing, that is securing this app using the FIDO security key. But we choose to build a web wallet. So the idea is that because you don't have access to the security APIs to protect your secrets, like you do on a native app, we use a different source for hardware security, which is the FIDO security key. It means that all the data that is stored in your wallet is encrypted, and you actually need to have your security key to decrypt it. So the idea is you can still store it in local storage in your browser or on a web backend, but it will be encrypted. And if you need to actually sign something or to disclose some information, you use your security key to decrypt the contents of that wallet and do a presentation, for example. So we built this wallet. It's more like a reference implementation. We're using it in the pilots, in the large-scale pilots in Europe. But it's open source. Everyone can have a look and use the same technologies to secure any wallet, basically. So this is the idea. I think this picture has been on the slides many times during this conference. We have issuers, verifiers, and then there's the wallet in between. And it's now drawn as a mobile app, but it could also be a desktop browser. And the idea is then that this web application doesn't do anything with security because the security depends on the FIDO security key. The FIDO security key is doing all the crypto. So there's actually three things that the security key can do. The most obvious thing is to authenticate. So, for example, if you're storing your encrypted contents on a web backend, you can authenticate to that backend to say, okay, this is my content. So that's an obvious use case because that's what everyone's using FIDO for. But there's two new things you can do. So you can just decrypt the contents using a key that is derived from, so that's a device-bound decryption key. And you can sign the presentation. So your proof keys can also be derived from that same FIDO key. So that's the goal we are trying to achieve. So you might wonder why FIDO security keys? Well, you might think, okay, why can't we use more traditional technologies like smart cards? Well, because they are very hard to use from the web. While FIDO has been designed for the web, so it's much easier to leverage features from FIDO in a web application. And of course, all these nice features that we know from FIDO, like phishing resistance, that is of course very important for a web wallet. But also like things like hardware attestation, so you can, for different use cases where you need extra guarantees about where the keys, the decryption keys are stored, you can use FIDO hardware attestation to prove that that your keys are derived from a particular model of security key. So that's why we're looking at FIDO. And then why a web wallet and not a native app? Well, in Europe we have this thing about being independent. So it's a nice idea to be independent of the platform security features of the platform vendors like Android and iOS. But more importantly, it's easier to use the wallet from multiple devices. I've just been to a presentation about using a passport for account recovery, and the anecdote was that someone lost the phone and had to go through great pains to restore his identity. But if you have a web wallet that is encrypted and stored, let's say on a cloud service in an encrypted fashion, you can just as easily download the complete contents of your wallet to a different device and use then your FIDO security key to decrypt it, and you're good to go. So that's also an advantage. And then there's a special use case in Europe that's called an organizational wallet. That means that instead of having a private, so a personal wallet, you can have a wallet that is associated with your organization, that is used, for example, if you have to prove that your organization, so the organization that you work for, maybe needs to sign some documents for tax purposes or something. And then it may feel unnatural to have your personal device carrying your organization's keys. So it's a more natural fit to have a web wallet for your organization. And then lastly, also not unimportant, is that it's more inclusive to have this web application, because you can run it anywhere. So you don't need to buy an expensive phone to use a wallet. And this is important in some countries where, and also because it's mandatory, right? It's mandatory to have this accessible to any citizen in the EU. So that's a nice feature, that you don't actually need to have a mobile phone. So let me give a very quick demo. So we have this website. It's called demo.www.wallet.org. You can try it yourself. If you don't have a FIDO security key, you can also use it with Android, because the features for the FIDO features that we use are also implemented on Android devices. So here's the front page. I already have some credentials issued, but let's just log into this website. So this can be a brand new browser. I've never used the wallet on this browser before. So let's just sign in. So this is a pre-recorded movie. So this is the FIDO security prompt that you may be familiar with, and actually that's it. And so this is very similar to any wallet demo you've probably seen. But the thing is that underneath, when you signed in, when you typed in your PIN, your key was unlocked. And all the keys that are required to download and decrypt the wallet contents were made available. And then after decryption has been done, these keys are destroyed again. And the point of this demo is that you don't actually notice this. And of course, there's not so many credentials in there, but eventually you'll gather lots and lots of credentials that are stored here. And they're just as easily decrypted. But in this case, it's based on a key that is derived from the FIDO security key. So let's see another demo. So here's a verifier. So this is the demo we use in the DC for EU pilot that is concerned with academic credentials. So one of the credentials that you can store on your wallet is like your university diploma. So let's say we have an employer, a potential employer, and you want to apply for a job, but you need to prove that you have a certain university degree. So we're signing in here. So this is a demo you can also use. Here I select several use cases, so I'm going for the diploma use case. I don't need to scan the QR code, I can just click, right, because it's a web browser. So here you see I can select my credential, and I'm redirected back to the verifier in this case, which can actually check that one of the, so this is a technical demo, but one of the attributes that, or the credentials that are being disclosed is my university diploma. And again, this is very similar to other demos, but the thing is that all the crypto in this demo has been derived from this FIDO security key. So how does this work? Let me quickly explain. How many of you are familiar with the PRF extension, the FIDO extension? I don't expect too many because it's fairly new. But it's actually implemented. Chrome has implemented it. It's also implemented on Android. And PRF stands for perfectly random function. So it's an extension you can use in a FIDO transaction that will generate random data. But you can use that random data to derive encryption keys, for example. Because every time you send the same challenge, you get the same answer. So this is what we use in the web wallet to derive a decryption key from a FIDO authentication. So the moment you authenticate to the backend, the PRF extension is used to derive the decryption key. The encrypted content is downloaded from the server, and it's decrypted on the fly. So that's how we do encryption of the wallet contents using FIDO. So how am I doing in timing? Perfect. So let me also quickly explain what's happening underneath in the current implementation of this wallet. So let's say we have we're creating a new wallet. So if you do the demo, you say, okay, create a wallet. This is what happens. First, a key pair is generated because you need a signing key. Because every time you do a presentation, you need the signing key to sign the presentation so that the verifier can actually verify it. So we need a signing key, so that has been generated. But to protect the signing key and other data, we have also a wallet encryption key. So this is the key that encrypts the complete wallet contents. And then there's yet another key. Oh, let me first explain that. So the wallet encryption key is used to encrypt the user signing key, but also the rest of the content. So if you have credentials, that's also being stored there. But initially, we don't have any credentials, so we just sign we just encrypt the signing key. So there's a key hierarchy, and it's not the end because there's another one that we call the wrapping key. And the wrapping key is derived using the PRF extension from the FIDO security key. So there's lots of keys, and the reason that there's this many keys is because we want to have this organizational wallet, and we want to have backups of our security keys. Because if you lose your security key, then you have a problem because you're no longer able to decrypt the wallet contents. So typically, you would like several FIDO security keys to encrypt or to use your wallet. Now, we could, of course, skip the wallet encryption key and use the wrapping key directly, but that would mean that once we gather lots and lots of credentials, we need to have multiple copies of the encrypted data because the different security keys will always generate different wrapping keys. And this is inefficient, so we instead of doing this, we have multiple wrapping keys that will all encrypt the wallet encryption key, so we only have multiple encrypted copies of this encryption key, and we only have one encrypted wallet contents. So this is a more efficiency argument. But it does mean that we can have multiple FIDO security keys to secure the same wallet. So the wrapping key is used to encrypt the wallet encryption key, and the wallet encryption key is used to not only encrypt the signing key, but also the rest of the contents. So let's say we want to do a presentation. So how does that work? So the idea is that if we're not using the wallet, there's no secret, so no private keys in memory. So everything is destroyed. But of course, if we need to do a presentation, then at that point we need our signing key. But at that point, the signing key is still wrapped. It's encrypted using the wallet encryption key. And the wallet encryption key itself is also wrapped. So how do we sign this signature request? Well, of course, we use our security key that will derive the wrapping key. The wrapping key is then used to decrypt the wallet encryption key, and then the wallet encryption key is used to decrypt the user signing key. And then, because we have the user signing key available now, we can actually sign the signature request, and the signature is sent to the verifier. The verifier uses the credential to do whatever the use case is. So this is how we implemented it today. But that is very close, but not sufficient for some use cases. Because, as you might have guessed from the diagram, all the keys are derived from the FIDO security key, but that means that the signing takes place in software, not in hardware. What we would actually would like to have is that the signing is done on the security key itself instead of in software. So this is currently not possible, and that is why we are working on an extension to the WebAuthn specification. And actually, there's now a pull request open on the WebAuthn spec for a couple of extensions. One of them is the WebAuthn signing extension, and this signing extension can be used to sign using a key that is generated on a security key itself. So that means that this key is not it's not possible to export that key from the security key. And this is important for some use cases because, for example, if you have a verifiable credential that is issued by a government, there's extra requirements on the private key. So the private key has to be stored on secure hardware, like a FIDO security key. But of course, to sign this, we need this extension because, of course, FIDO also does signing, but it's signing a WebAuthn challenge, and that is not an arbitrary challenge. That is composed of all kinds of different data elements. So it's not possible to do raw signatures. This FIDO extension enables raw signatures. And this is what we need for wallets, but it has other interesting applications as well. One of them is actually one of the use cases here is signing documents, for example. So to sign a PDF, for example, you could use this extension. But there's several other applications. This is, for example, used in some password managers. So password managers can now also store passkeys, but they are stored in the cloud. And then the question is, how do you protect your vault? Well, you can use a security key for that. So things like these extensions can be used in lots of different applications, and that's why there's interest from the vendors to actually support this. But it's still early because it's a draft, so we'll have to see in the future. Then there's another algorithm, it's called AKRG. That's less important for now, I think, but this has to do with the fact that there's this thing called user presence. When you do a FIDO operation, you need to actually touch the FIDO security key. And there's this requirement in the EU that proof keys need to be unique for some use cases, because if you want to have if you want to remain anonymous, you cannot use the same key twice, because otherwise the relying party could track you based on the public key. So this means you have to have several public keys and private keys, so key pairs, for every verification. But you don't want to. So what happens is that you typically want to generate lots of keys, but you don't want to press the security key every time. So if you want to generate 100 keys, you don't want to press your key 100 times. So this is what the ARKG algorithm is for, and it also has different applications, so that's why it's also being standardized, but that's done in the IETF. And it originates from a different use case, but it happens to be a perfect match for our purposes. So this is also something that has been submitted to the IETF for standardization. So to recap, it is still work in progress, but the pilots will run for some time. In the meantime, we are working on this wallet, and we're trying to move from the way it works now to the way we envision it to work, using this signing extension and the AKRG algorithm. Unfortunately, we have time because the pilots will run for at least another year. So this is a nice, let's say, parallel tracks to work on the pilots in the EU and also to work on the extensions for other use cases. So I have some resources here if you're interested. So the extensions, if you're interested, please have a look, because we're also looking for feedback on them. And if you want to try it out, it's demo.www.wallet.org, and you can use it on Chrome and Android. So I think we have some time for questions. I have a question there.
What if you lose your security key? So then does that mean that your wallet is locked forever? Recovery mechanism?
Yeah. So the question is, if you lose your security key, you lose your identity, and the answer is yes, unless you've used multiple security keys. So what you could do is you could, for example, if you only have one security key, you can also use your Android phone and a security key. So you'll have two, and one is the back of the other. It may only be that if you're using Android, because it doesn't have the attestation, you cannot use it for some use cases. But if it is important, you can have two FIDO security keys and enroll both. Put one in a safe somewhere, and just use the other one until an accident happens.
So which attestation are you talking about? So essentially, like if I use a platform authenticator which syncs across, does it provides PRFS, but it is syncing, right, like across multiple devices or whatever. Does it provide the same level of security that like a hardware bound security key does?
Yeah. So the question is, if I understand correctly, what is the attestation part? Because if you have a syncable passkey, there's no attestation, and that is correct. So that's why we're focusing on the FIDO security keys where the attestation is present, because only with the attestation you can actually prove the provenance of the key. But for the demo, because the Android platform supports the PRF extension, you can use it for now. Whether that is possible in the resulting wallet in the EU, so the digital identity wallet for the EU, that remains an open question, because it's at this point not clear what the exact requirements are.
Just one more point, like adding to that, so the whole reason to have a web wallet was because, like, to make sure that like people who doesn't even have like a high-end phone or whatever without a TPM can still use them. But if we introduce security key in there, that's an additional requirement where you need to buy a piece of hardware which a lot of people honestly might not have. So
Yeah.
so that's why like this platform authenticator and that provenance becomes important. So is there some more going on regarding that?
Yeah.
In the FIDO community?
Yeah. So the question is, what good is the web wallet if you, instead of so you don't have to buy a security key? So that's still an issue for some users. But well, first answer I think is that a FIDO security key is a lot cheaper than an Android phone or an iOS phone. But the thing is here that in the EU there will be some requirements on the protection of the private keys. So if you have a signing key, if you're proving something that is, if you're buying a house and you have to prove it's you, then I'm sure there will be a requirement on how that private key is protected. And well, here we'll leverage the FIDO attestation and the FIDO certifications, so you can actually prove that this key is okay. This is compatible. Well, sorry, this is compatible with eIDAS, and maybe it's nice to know that FIDO security keys are already used in eIDAS in, for example, Czech Republic and I think also in Norway, because they are notified eIDs in those countries. And one of the requirements is that it's level 2 certified. Well, something similar will probably be required here. And yeah, unfortunately, Android is not level 2 certified. Other questions?
Can this solution work offline?
Will the solution work offline? Yes. Although the demo doesn't work offline yet, but that is my remark about progressive web apps, because they can be made. So what happens is, if you have a progressive web app, you can choose to download everything to the client, and then it will still work, even if you don't have network access. So that is intended, but it is not completely clear yet how the communication with the verifier will take place. So that will normally be over the internet. Of course, you can scan a QR code. Then, of course, the request can be scanned by the wallet. But then the answer needs to travel back to the verifier. And yeah, we're still experimenting with that. We have some demos with NFC. But yeah, those are still... that's still work in progress. But the intent is to have it work in offline scenarios as well. Yeah. I think we're 2 minutes over time, so thank you for your attention.